What's up, my first class Falcons? This is Miss Pearl. We're still on 7-3. I'm going to go through two more examples with you. The table shows one student's results from spinning the pointer 30 times. Complete parts A and B. A. Find the theoretical and experimental probabilities that the pointer lands in a section with a number greater than or equal to 2. So the theoretical probability is numbers 2, 3, 4, and 5. So that's a total of 4 out of 5. That makes sense? Okay. You have 4 outcomes out of a total that you want out of a total of 5, which equals 0.8 or 8 tenths. And now let's get a percent, which equals 80%. Again, your theoretical is what you think should happen. All right, now let's talk about our experimental probability. What actually happened? So they spun it 5 times, another 5 times, and got 3. They got 4 7 times, and they got 5 4 times. Let's add up those numbers. Out of a possible 30 outcomes. All right, so our experimental probability was landing on a number greater than or equal to 2, 21 out of 30 times. So let's get a decimal. Again, you're going to do top divided by bottom, 21 divided by 30. Now you get 0.7 or 7 tenths as your decimal. Now let's change that into a percent. So we're going to multiply by 100 and we get 70%. Nice work. All right, then the question goes on to ask, what might have caused the theoretical and experimental probabilities to be different? The first one says the experimental probability only matches the theoretical probability in a very small number of trials. So that's not true. It is more likely to match in a large number of trials. B says the spinner is not a fair spinner. Well, I don't even need to move on because it is a fair spinner. Everything is equally spaced. C, the spinner is not a fair spinner. Just skip that. D, the experimental probability of an event occurring is not guaranteed to match the theoretical probability, but with more trials, they should get closer. So this is true. It's not always guaranteed to be exactly the same. And this is the last question I'm going to go over with you. The table shows the letter grades in science class for a random sample of 300 sixth grade students. Find the relative frequency for each letter grade to complete the table. Use pencil and paper. What additional information does the relative frequency give that the frequency doesn't? All right, so let's look here. So to find our relative frequency, we're going to do the frequency for A is 36 out of 300 sixth graders. All right, and we can use our calculator. We're going to get a decimal answer. So that means you're going to do top divided by bottom. All right, and we're going to get 0.12. Now again, they weren't all that clear because the past examples, they wanted you to find a percent, but they don't have a percent sign here. And it tells you to round to the nearest hundredth as needed. So that's how you know that they want a decimal answer. All right, now for B, we're going to do 49 divided by 300. You get 0.16 and 3 repeating. So again, we're going to round to our nearest hundredth. So that rounds to 0.16. All right, so for C, we have 111 out of 300. Same thing, top divided by bottom. And we get 0.37 or 37 hundredths. D is 60 out of 300. And you get 0.2. And F is 44 out of 300, top divided by bottom. And we are going to round that up. So we have 0.146 repeating. The 6 rounds the 4 up to 5. And we get 0.15. Nice work. And that's all the examples for 7-3. If you have any questions, email me and we can even set up a Google Meet if you need more help than that. All right. Thanks. Bye.